Hello and welcome to this ParaView Python webinar. I'm Mathieu Westphal. I will be your host today for this webinar. So I'm a ParaView expert engineer at Kitware. I've been working on ParaView for at least 5 years now, and especially on the Python part. So first, I will suggest you to check that you have access to the chat. So the chat should be on the right side of the video. If you cannot see it, okay, maybe you don't have sound right now. Mm. Okay, it appears I may not have sound. Oh, I do have sound. I do have sound. I have the sorry, I had a wrong feedback here. Okay, so let's get back to it. So yes, you should have access. You should have access to the chat on the right side of the video. If you don't have access, just increase the size of the window and make sure you can just say hello, like everybody is doing right now. So yes, thank you very much for the feedback. It's very nice to have feedback in the chat when I'm interacting with you. So yes, thank you. If you have any questions during the webinar, just ask on the chat and they will be fed back to me. Okay, so if you don't know what is Kitware, so let me introduce it very quickly. So at Kitware, we develop many open source solutions, of course, including ParaView, but as well as VTK, LadaView, Slicer, and many others. So we provide different courses on VTK and ParaView. We provide development services and support on all our products. So, so Remy has a question. Okay, so let's go. So let's start with the planning of today. We start to cover the basic usage of Python in ParaView. Why should we use Python? Where is Python available in ParaView? We will then go to how to use the trace and use the macros. And then I will talk a little bit about tips and tricks and how to go forward. And then I will talk about programmable filters, which is a bit more advanced way to use Python in ParaView, and introduce the Python annotations, the Python calculator, and then talk a little bit about programmable filters. So, why should you use Python in ParaView? First, well, sometimes you just want to automatize some tasks, some repetitive tasks you want to do in ParaView. Sometimes you have a complete workflow that you have been designed in ParaView and you just want to always use the same workflow and again and again and again. And for that, you can use Python in what we call the batch mode. You may want to use Python to generate videos or generate lots of screenshots. Another way to use Python is to implement a feature gap. What we call a feature gap is basically when you have all your pipelines, but you only miss a little part in the pipelines that is very specific to your workflow. Then you can implement that in Python. Finally, what you can do with Python is use it as an interface to connect ParaView with other tools. There are multiple examples of that. For example, there is Jupyter that lets you connect a Jupyter kernel to ParaView with some kind of specific plugins that have been developed by Kitwa. And another example is LiDARView, which rely heavily on the Python interface of ParaView to work. So, if you want to follow along and take a look at the different tools I will show you, you can just run ParaView and try to follow along if you want. It's not necessary, absolutely. All the topics we will cover today are mostly aimed at beginners in ParaView, but if you are an advanced user, still fine. You can, of course, follow, and maybe you will learn a thing or two. And if you've never used ParaView before, it's okay. I will go slow, and if you have any questions, please do ask in the chat. Okay, so where can we find Python in ParaView? So when you open ParaView, this is the basic, usually the interface you get. And here you can, of course, create sources or open files and everything. But if you want to look for Python, the first way you can open it is through View and then Python shell. Here, it will open a new window, well, a doc widget exactly, where you can just click on it, and then here you have a Python shell. You have basically a Python interpreter, which is embedded within ParaView. So here you can do everything you do in the GUI, you can do it in Python. So for example, here you can add a sphere, which is exactly the same as clicking on source and add a sphere source. You can then decide to show it. If you show it, it will be the same as clicking on the eye in the pipeline browser, here. And usually you call render. Here, as you can see, we did not need to call render because we are within ParaView. But always remember to call render to make sure that you will have an image that will be rendered in the window or for your screenshot. So this is a very basic usage of Python in ParaView. Just create a source or open a file, show and render, and you're showing something. Okay. So, but everything you do in the Python shell within ParaView, you can do in another tool we call PVPython. It's available alongside ParaView. Usually, when you want to run PVPython, you have to run from a terminal because it's basically the same as a Python interpreter. So just alongside ParaView, you can open PVPython. When you run PVPython, you have basically a Python interpreter, but you have access to all the Python interface of ParaView. First, you need to run from paraview.simple import star. And then you can do the same thing as before, as in the Python shell. A sphere, and then show, and then render. If you want to be able to interact with it, you can just use the interact method. This way you can, it's basically you have a ParaView render window right now, and you can just do anything you want with it. When you finished interacting, just hit the Q key on your keyboard to be able to enter more commands. Okay, so that's another way to access Python within ParaView. So another way is to access Python is to use macros, and but to be able to use macros, you will need to learn how to write Python code, because I've just shown you the sphere, I show you how to show, how to render, but of course that's not enough. You need to learn a bit more. The easier way to learn about the different Python command within ParaView is to use a trace. So what is a trace? The trace is the Python trace is a tool that lets you record everything you do in ParaView in the interface. Let's say you create a source, you open a file, it will record everything, and it will store it in a Python script that you will be able to run in the future. So let's try to do the same thing as before, but just record it as a Python trace. So tools, start trace, you will be able to find it here. Okay. And we can do the same thing as before using the interface of ParaView. I create a sphere, and basically show and render is already done. So I can just tools, stop trace, and here it is. I have a full Python script that is doing the same thing as I was before. You can see that there is many more lines than what we were doing before. That's normal, because this is generated code, so we need to store many more information that's actually necessary. But it's okay. And if you take a look at the end, you can see that you have render all views, or it suggests you to add a save screenshot. So what we will do here is just uncomment the render all view and save as a file somewhere on the desktop. So now, when I've deleted my sphere, I can just run the script from the Python shell. Here it is. So I have a very good question from Bernd right now. It's asking if he can use PVPython, to use PVPython, or should he use Python from ParaView, or can he use Anaconda environment? So that's a very good question, and that's, to be honest, a question we get a lot. So if you're using the release of ParaView, like the binary release of ParaView that you download from ParaView websites, you cannot use Anaconda. And you need to be able to use Anaconda, you basically need to build ParaView yourself with Python, the Python provided within Anaconda. That will be the only way currently to do that. We do have some plans to support a version of ParaView that will let you bring your own Python, and it could be Anaconda in that case, but this is not ready yet, and I cannot give you an estimate for when it will be ready. So I have another question from Simon. Is it possible to use PVPython without actually rendering the data with LS without opening the 3D view, in order to just run the data and run some tests of the data without rendering the data? That's absolutely possible. Instead of using show and render, you will just use update pipeline. And when you run update pipeline, it will update the pipeline, of course, doing all the computation, and but it will not show the data at all. It will just do all the computations, and you will be able to do anything you want with the results. To be able to, let's say, make a quality check, and as Simon says, you will need to be able to access the data, and for that you will want to use fetch, but I will talk a little bit about it later. I hope that answers the questions. Let me take a drink. And let's get back to it. So I've shown you how to run the script from the Python shell. You can do exactly the same thing from PV Python. So here I have my PV Python, and I can just give it my trace. Well, it's going a bit fast because once the render is done, it's just closing. So you can just edit it to use interact instead. And here you go. So if you want to do something with Python and you don't know how to do it, just trace it and then analyze the trace, modify it to your needs, and you will be able to learn PV Python very, very fast. Oh, yes, very good question from Michel. What is the advantage and disadvantage of PV Python with respect to PV Batch? I usually use PV Batch to run my Python script generated from the trace. So I have not talked about PV Batch yet, and I should. So if you take a look at here, you have PV Python, but then you also have PV Batch. So what's the difference here? So as you can see, you cannot just run PV Batch and give it interactively some Python code. You need first to give it a full script. And also you don't have any rendering capabilities, as just said Michel. But the main difference between PV Python and PV Batch is that you can run PV Batch in parallel. So you will be able to run with MPI. So it's a bit an advanced trick. So I will not give the specifics about MPI run and how to use it. But basically, if your pipeline is made to run in parallel, you will be able to trace it or create a script, a Python script, and then running it in parallel and have some speed up thanks to that. And this is not something you can do with PV Python. So you can only do it with PV Batch. It's thanks to the way PV Batch has been created in the building of ParaView. I hope that answers your question, Michel. Okay, and so what I wanted to talk about then is, where is my ParaView? Right here. Is macros. So as you have seen before, when we add a trace, we just save it as a script. But you can also save it as a macro. When you save it as a macro, and you can just, it will create a button in the interface here, right here, action, and this action you will be able to do it anytime. Just click on the button and you will have the action. So I will give an example right now. Let's say every time after you've created some very nice visualization, you just want to add some logo and some text to your screenshots, because, well, that's what you need to do for your organization, let's say. So I just generate a nice image first. Okay, let's say I'm done here. This is the thing I want to generate, and I need to brand it with my company logo and name. So I will just start a trace. So we'll add a text. So here, company name. Okay, and let's say I want to add a logo. Here it is, a logo. And yes, that's it. I have my trace here. I will just instead of saving as a file, I will just save as a macro. So I already have one, so I will create another one. Okay. And now every time I want to add the text and the logo, I can just click on the button and it will just add them right here. So this is just a very simple example, of course. You can do much more complex things in here. It's basically the same as clicking on one script and running the script. But so this is a very simple way to add some elements to the UI of ParaView. Okay, so you have basically all the basic tools now. You know how to create a trace. You know how you should read the trace to understand it, try to understand it, and take the piece together. But if you want to go forward, you need to take a look at the documentation. So if you look at the in the Vimeo description, you have a link to the documentation of PV Python. And let me open it. Yes, right here. Okay, and here you can access all the information about PV Python. So I would suggest you to take a look at the getting started. It will basically give you all the information I just gave you today, but with a bit more detail in a textual form. And once you understand everything that's within the quick start, you will want to take a look at the simple package. In the simple module, you will find everything you need, basically almost everything you need with PV Python. All the different methods, all the different interactions you do in the GUI, you will find in the simple module. How do you access the simple module? Well, the simple module is anything you enter in the Python shell or in PV Python is within the simple module. If you want to access other module, you need to use the module name, but for the simple module, it's already there. And if you want to go forward, there is a few tips and tricks. There's a few tips and tricks I can give you. So the first tips and tricks, I actually found out about that not so long ago when I was trying to change the representation within Python, because here right now I'm showing the code, right? So you can see the code, and right now we are using surface representation. And so if you recover the representation of the code right now, using show is just a simple way to recover the representation of the active source. And right now I have a geometry representation. If I take a look at the representation as a representation of the representation, thanks for the names, and right now it's surface. But let's say I want to have a point representation. I don't know the name, right? How am I supposed to know? Oh, point is not defined. And if I take a look here, I can know it's points with an S, but when I'm within ParaView, it's possible. If you're watching your script in your Python editor, it's not easy to have access to that. If in your Python interpreter, it's not easy to have access to that. So what you can do is use available. If you use available, it will just give you all the possible values for this property. So and here I can see, oh, it's point with an S, and do something like that. Oh, it's within quote because this is a string, and I just need to render again, and here it is. I have points instead of surface. So available can be used with many properties. all the properties that are shown as a combo box within ParaView. So a combo box is basically something like that, or like this. So you can use available to have access to the different available properties, to the available values for this property. So that's a nice trick, and I suggest you can use it when you are using Python in a dynamic environment. Okay. Another quick tips I can give you, and where is it? Okay, so oh yes, the SM proxy. So sometimes if you want to access a property of a filter, because in PyPython each property of each filter is available directly. For example, here with my when I create a sphere, I can change. So here is my sphere. I can just store it using getActiveSource. You can check out the simple documentation about this. And here I have S. S is my sphere. So if I can just check the radius, I can find it here. And every single property is available using this interface. For each filter, each source all the properties are available this way. But sometimes, for some specific reasons, and a property will not be available. So in that case, you can use the SM proxy interface. It's a bit more advanced, but if you know for sure that there is a property and for some reason it's not available directly, you can just use this interface using SM proxy and get property. So right now, this way you will be able to access the value of the data the same way as you access it. It's a bit more complex to access, but you can do it this way. Okay, and the last tips and tricks I want to show is fetch. So fetch is much more advanced, and but it's still a very nice tool to have when you're working with data that you want to have access to when you are on you have some small data you want to be able to access the actual value. Exactly what you may want to do in a spreadsheet. For example, you open a spreadsheet, you want to see exactly what are the values on the spreadsheet here. If you want to do something like that in Python, you basically need fetch. Fetch is available in Server Manager. This is a method that lets you recover the actual values of the data. So if you're interested by that, I would suggest you to take a look into the fetch documentation in the Server Manager module. Okay, so that was the first part. We will go then to the second part about another way to use Python in ParaView. And it's a bit different because everything we've been using right now is from the ParaView module of the ParaView Python module. But you can also use VTK Python within ParaView. So first, what is VTK Python? VTK Python is a Python interface for VTK. So VTK is a framework used by ParaView to create all the visualization, all the filters and everything. So with VTK Python, basically you can write or use VTK filter or even write VTK filter directly in Python. So this is something that is available in ParaView. So it is available in multiple ways. So the first way is a Python annotation. So the Python annotation this is a very powerful tool. So the Python annotation is a very powerful tool. It doesn't look like much, but right here in the expression part, you can basically write a Python code that will display something on the screen. So of course you can just write any kind of mathematics, but as you can see here, you also have access to different values. So for example, you have access to the current time step. So if you open temporal data, like this one, and I add a Python annotation, I can use t-value, I think. Yes, and this will just display the actual value of the time step. And you have access to a few other values that are provided here in the quick help. You can also use directly mat text annotation to be able to show some let's say some mathematical values. So I can give you an example. And also you can access directly the data. So for example here you can you have the vel data, which is a point data, and here you can use, if I'm not mistaken, no, that's not the right one. Well, this data is a bit big, but you have access to the data, and you can even compare multiple inputs. So that's one of the main difference. That's one of the main difference with the calculator. And with that's one of the main difference with other tools that you have in ParaView, where you cannot use multiple inputs. With the Python annotation, you can use multiple inputs. You can compare different values. And this is a very versatile tool. So if you're interested, there is a wiki page about it. So I would suggest you to take a look into it. Secondly, there is a Python calculator. So it is the same idea as the Python annotation, but instead of a text that you will display on the screen, this is instead just a computation that will be stored on your data. So that's the same idea. You have access to the same value. So the help is not complete here, but you have access to the same value, the t-index, and everything. You have and you also have access to the data from the inputs. You can also compare multiple inputs and this kind of stuff. Okay, and just to finish, there is a programmable filter. So programmable filter is basically the last tools. This is the most versatile tool within ParaView, but also not the tools you want to use at first. At first, you should try to. Use all the actual filters within ParaView, and then if there is something that the filters cannot do, you can, only in this case, you may want to use a programmable filter. Why? Because, well, a programmable filter will be written in Python, and Python is not the most efficient way to deal with data in general, compared to C++, I mean. And so that's why you may not want to use it right away. But it's very versatile because you can just implement anything you want to do directly in VTK Python, and you will able to have your results the way you want to do it. I can give you a quick example. So you can find programmable filter example in the description. And I will just show you a quick example. So I just copy and paste the first example from the wiki. Here you go. How does that look like? Well, we cover the input, we cover the output. We compute new coordinates for the points, and we just set the new coordinates as the new points. So basically, everything that is doing is transforming the data from transforming the point from one point to another. The geometry stays the same. So that's why the result is this a little bit flatter sphere. It's not a sphere anymore. And I will, of course, not get into specifics today with a programmable filter, but I think you can understand how powerful it could be. But what you write here is not PV-Python. You should not write sphere, show, and render, this kind of stuff. You always need to write VTK Python. So if you don't know about VTK Python, well, you will need to learn. There is no better way to say it. So let's say it's a bit more advanced tool. Okay, so that cover all the topics I wanted to. Oh, I have a question. Can I run a programmable filter as an action? Oh, that's a very interesting question. Thank you, Bert. So, how to answer that? That's possible. That's not obvious, but that's possible. Well, to be able to do that, the most easy way to do that is just to add your programmable filter and start the trace, then add your programmable filter, then stop the trace. It will provide you with a trace containing your programmable filter in a special way with triple escape quote, and you can save that as a macro. Then when you will click on the macro, it will create the programmable filter with the right script. But basically, the VTK Python code will be as a string within your PV Python code. Yes, that's how you can do it. I have a question from Tobias. Any combination of existing filters should be done via macros. And I'm not sure to follow. Oh, you mean just using multiple filters in a single macro? Yes, that's definitely possible. You can just start your trace, add every single filter you want to add, and that's it. Just save as a stop your trace and save as a macro. Okay, so if you have any remaining questions, now will be the perfect time. So I will just give you a few seconds to ask any remaining questions you may have. And yes, very good point from Charles. You can use a custom filter, which is not implemented in Python, so that's why we didn't talk about it today, but yes. Can I show examples from a question from Tom? Can I show example of running in parallel for speedups? Well, I will not be able to show an example right now because I don't have anything ready for that. But that's definitely something that is possible. Let's say that, what you need to keep in mind is parallelism in ParaView is basically a spatial distribution of data. So well, what I mean is you need to be able to separate the data in multiple spatial parts, and then every single filter will be able to process the data part by part for each core. Each core will process a part of the data, let's say. Of course, it means there is some communication and stuff, so there is some overhead, and but it's not specific to Python in ParaView or anything. Just that if you want to do that with Python in ParaView, you need to use PV-batch. And but this is a bit out of scope of today. I can suggest you to take a look in our wiki. There is some explanation about parallel in ParaView. I hope that answers your question. Is there another question from Tobias? Is there an easy automatic way to get the GUI pipeline in the Python shell? I'm not sure to follow. Is there another easy automatic way to get the GUI pipeline in the Python shell? Or you mean to have a visualization of the pipeline within the Python shell? I don't think there is, and that's like something like a tree or a graph or something. And I don't think there is something like that. That's something I think I tried to just implement a quick way to just sort the different. Just follow the pipeline and just show something. But I don't think it's been merged or anything. So nothing like that. But it should not be very hard to finish that and just add a quick method to just okay, here is how my pipeline is. So please, Tobias, if you are. Oh, no visualization, just that. Oh, the source. Okay, the source names. Okay, sorry, I did not follow. So yes, you can have access to all the sources. You have the method which is called get Python sources. No, get sources. My bad. Something like that, yes. So using get sources, you have basically all the source and the filters directly, and you have access. I don't know if you can read easily because it's in green, but you have access to the name and the ID of the of each filter and its sources. And then you also have the find sources that takes a name. So if you know the name, you can just recover it this way. And you also have the get active source. So I hope this helps. Okay. So well, I hope you have seen everything you wanted to see. I agree that's a very quick and kind of condensed way to look at Python in ParaView. But I hope that I answer many of your questions. Thank you for coming. That was very nice to have many viewers, and I just want to tell you that we do have courses coming up. So there will be ParaView user courses and ParaView advanced courses in October. If I'm not mistaken, it should be October 12 and October 13. But I just want a quick check from Charles would be nice. And yes, if you have any questions, you can go to our discourse, ParaView discourse. And if you find issues, you can just go to our GitLab as well. Please go to the discourse first. And of course, we also provide professional support. So if that's something you may be interested in, we will be very happy to oblige at Kitware. We do hope to keep doing webinars. So stay tuned for the next webinar. It may be next month if we are able to keep on our schedule. And I hope you all have a very good day and see you next time. Bye-bye.